So yesterday we ended up stopping right here where it says day 2. We stopped right there. Yesterday we factored out GCFs, factored out the GCF. But what if I asked you to factor out the greatest common factor of this polynomial? Like you can't pull out an A, even though you think, oh, maybe there's an A in common in all four terms, but there is no A in the fourth term. There are no B's in common in all four terms. Here's a B, here's a B, here's a B, but there's no B right here. So when you're trying to pull out a GCF, there simply is not a GCF. Even the numbers like 12 and 15, you're probably thinking, oh, maybe I could pull out a 3. 12 is divisible by 3, 15 is divisible by 3, but 16 is not. So up until this point, we would just say that it's not factorable or that it's prime. But that's only because we don't have the skills yet. Today, we're going to learn our second tool of factoring. And the second tool of factoring in our factoring toolbox is factoring by grouping. So we're going to come back to this one in a little while. Right now, I want you to look at the top right corner. It tells you steps to factoring by grouping. So this is going to look weird. It's going to sound weird, but if you pay attention, it's going to make sense and it'll be easy. All right. So if you read right here along with me, step 1 is separate a polynomial into 2 groups. So you see right here, we have 4 terms. We have x to the third plus x squared plus x plus 1. And step 1 is to actually separate the first 2 from the second 2. All you do is take these guys and separate them and leave a little gap between them. Okay, so that is step 1. All you got to do is separate into 2 groups. Step 2, factor something out of the first group, factor something out of the second group. All right, so let's go back to our groups here. I don't want to show you the answer already, but if I asked you, what could you factor out of this first group, you would say x squared, right? X squared. So you'd have parentheses with the x squared out here. And that's exactly what I have right there. Parentheses with the x squared out here. If you do pull out that GCF of x squared, what would be left on the inside? X squared times what gets you back to x to the third? X, right? And then over here, x squared times what gets you back to x squared? Yeah, that's right. Plus 1, right? Does that make sense? Okay, now the instructions say factor something out of each group, out of both groups. So we pulled out the GCF of x squared. Over here, there's technically nothing to factor out, okay? So I'm going to put parentheses. Normally, I wouldn't factor anything out, but however, they want us to factor something out of both groups. So I'm going to forcefully pull out a 1, okay? If I pull out a 1, inside of the parentheses, it's going to be the same exact thing. Does that make sense? Okay, so that was step 2. Let's reiterate. Here's your original question. Step 1, make some space between your first 2 terms and your second 2 terms, creating 2 groups. Second step, pull something out of the first group, pull something out of the second group. Even if you can't pull something out, pull out a 1, just so it seems like you're pulling out something. And now if you read step 3 up here, it says, take a step back and factor the common binomial out of the 2 groups. So take a step back and pull out the common binomial. So what do I mean by that? I usually do some exaggerated parentheses, and you see how there's a x plus 1 here and an x plus 1 there? I'm going to take those x plus 1s and pull them out over here to the front. So you'd put x plus 1 out here in the front. And then what's left over, if you pull out that x plus 1 and you pull out this x plus 1, what's left over, if these are gone, the x squared and the 1 is what's left over. So you'd have a x squared and a plus 1 left over. And ladies and gentlemen, that is your factored form. All you got to do is rewrite it with the correct size parentheses. So once again, step 1, make 2 groups. Put some space between your first 2 and your second 2. Step 2, factor something out of each group. On this one, we factored out the x squared. On this one, you couldn't factor anything, so we put the parentheses and we pulled out a 1, even though it's pointless to do that, but we're just following instructions here. After that, you take the third step, take a step back and pull out the common binomial that's in both groups. If you pull it out, you're going to end up with this common binomial out here in the front, x plus 1, and you have these exaggerated parentheses right here. And what's left over, x squared comes down and 1 comes down. The reason why I have blank spots here is so that you could visually see that the x plus 1s got factored out to the front and there's no longer the x plus 1s right here. Does that make sense? Okay. So, of course, you're not going to leave it like this with blank spots. You're going to write it with the correct size parenthesis, and that's your answer. Now, we just factored using a different method. It's called factoring by grouping. Factoring is still a reverse distributed property. So this is like if this were the answer and this is the distributed property question. Let me verify that for you. What is x times x squared? X to the 3. What's x times 1? It's a 1x. And yeah, there's a single x right there. How about 1 times x squared? 1x squared. What about 1 times 1? It's 1. So if you did distribute, you will get back to this original problem, okay? So we need to really get comfortable with factoring by grouping. Right now, you've just been listening and you've been watching. Let's actually follow along with these two examples that I am going to do. The teacher does it. You're going to follow along. So everybody go to number 1. And what is step 1? If you're like, oh, I don't know, read it. It's on your notes right there, top right corner. Separate the groups. So I'm going to rewrite this thing, x squared plus 4x, the same exact two terms, and then I'm going to leave a big space and put plus x plus 4. Please follow along. That's the first step. Separate into two groups. Okay, second step, factor something out of the first group. So what could I pull out of that first group? What's in common? What's the greatest common factor in these two terms? X. Pull out an x. What's going to be left over on the inside? X plus 4. And the process, the way your brain should be thinking is, okay, x times what gets me back to x squared? That would be a positive x. X times what gets me back to a 4x? That would be a positive 4. You're with me, right? You got this. Okay. Now, I need to also factor something out of the second group. However, there's nothing to factor out. So what could I do? Factor out a 1. Put a plus 1 right there. And of course, it leaves it exactly the same, x plus 4. Again, if you were thinking x or 1 times what gets me x? 1 times x gives me x. 1 times what gets me 4? 1 times 4 gives me 4. Anyway, that was step 2. Step 3 is to take a step back and factor out the common binomial. What does the word common mean? It means that they're the same. Binomial, two terms. Factor out the common binomial. So you have this binomial x plus 4, this binomial x plus 4. Take these guys, put them out here in the front. Okay, so I'm going to put the common binomial x plus 4 out there in the front, leaving me these giant oversized parentheses. And what is left over on the inside of those giant oversized parentheses? X plus 1. So let's do that. X plus 1. And that's your answer. X plus 4, x plus 1. So I would like you guys to move on and you're going to follow along with me doing number 2. So once again, step 1, if you're like, I don't know what step 1 is, read it from the notes. Step 1 is to separate them into two groups. So we're simply going to rewrite it. 9x squared minus 3xy, big space, plus 6x minus 2y. So as you can see, I have one group, I have another group. That's step 1. Step 2, factor something out of the first group. So here's my first group. What could I pull out of there? Not just what could I pull out, but what's the greatest common factor that I could pull out of there? 3 and an x. Now think about it. If you pull out that GCF of 3x, 3x times what will get you back to a 9x squared? 3x. That's right, a 3x. And how about this? 3x times what will get you a negative 3x, but with a y? Negative 1y. Negative 1y, or just negative y. You could put the 1 if you want, or not. And now let's do the same for the other one. What could I pull out of the other one?
2.
A 2. Yeah, because the number 6 and the number 2, like if it would have been a 6 and a 5, yeah, I would at least pull out a 1. But 6 and 2, you could actually pull out the factor of 2, right? So pull out the 2. And you can't pull out x's because there's no x's in both terms. You can't pull out y's because there's no y's in both terms. It's just the multiple of 2 that you're pulling out. Okay? So what would be left over on the inside if I pull out that 2? 3x, and then minus 1y, or just minus y. Again, 2 times what gives you 6x? 2 times 3x gives you 6x. 2 times what gets you a minus 2y? 2 times minus y gets you a minus 2y. Now, this is great. Why? Because notice that you have a common blue binomial. They're both identical. And that means that you could pull it out. That's step 3, pulling out the common binomial. I always do exaggerated parentheses. And then I always write down that common binomial, that little blue 3x minus y. I put it out there in the front. And if these were removed, what's left over? 3x plus 2. That's right. The 3x comes down, and that positive 2 comes down. And that's your answer. 3x minus y in parentheses, 3x plus 2 in parentheses. What do you think? Now, it's easy. Only if you're paying attention, right? If you're not paying attention and you don't practice this, this is actually challenging. This is pretty advanced algebra here, right? But if you're paying attention, yeah, it's going to seem easy. And if you're practicing, it's going to seem easy. So once again, just to reiterate one more time, all the steps. Step 1, separate it into 2 groups. Step 2, factor something out of the first group, factor something out of the second group. Step 3, take a step back and pull out that common binomial. They have to be identical for you to be able to pull them out. If this said 3x minus y and this said 3x plus y, I wouldn't be able to continue with this method of factoring by grouping. Or if this was like a 3x minus y and this is a 3x plus 10y, you wouldn't be able to factor by grouping. Later on, we'll learn different methods. So it's very important to understand that you need these binomials to be common. You need them to be identical so you could actually pull them out, okay? Before I let you try some of these, let's go over here. Way down here, we had this first example. This one is as hard as it could possibly get, all right? So on your paper, go down to the bottom left corner, and you're supposed to always try and factor out a GCF first, right? That was the first method of factoring that we learned. And that's the first factoring method you should always try. So for example, if all of these were divisible by 2, then I would factor out a 2. If they were all divisible by 3, I'd factor out a 3. But as you can see, it doesn't have a GCF in all of its terms. You can't pull out anything in common in all of its terms. So we're gonna jump right into factoring by grouping. Step 1 is to make 2 groups. So please follow along. 12a squared.
Where's that?
That's on the bottom left corner. Minus 15ab, big space, minus 16ab plus 20b squared. So we separated it into 2 groups. That's step 1. Step 2, factor something out of the first group. So what could I factor out of that first group?
3.
Definitely a 3 and also an a. That's your GCF right there. So working backwards, thinking 3a times what will get me back to this 12a squared? 4a. Okay, and then 3a times what gets me back to a negative 15a with a b? Negative 5b. Excellent. That's good. Now, here's the funky part, all right? When you factor something out of this one, this is why it's kind of more complicated. What could I factor out of this one?
4b.
A 4 and b, right? 4b. 4b. Now, how about this? Stop writing right now and just watch me do this, okay? Okay, so if I pull out a 4b, 4b times what gets you a negative 16ab?
Negative 4a.
Negative 4a, right? And 4b times what gets me back to a positive 20b squared? Positive 5b. Now, the reason why I told you not to write this down is because notice that the binomial 4a minus 5b is not the exact same binomial 4a minus 5b. It's actually minus 4a plus 5b. Does that make sense? So this 4b that I pulled out, it is the greatest common factor, but what would have been better if it would have been a minus, let me do it in red, a minus 4b. That would have been better because then this would have been a positive. Let me white it out here. That would have been a positive, and this one would have been a negative, thus producing the same identical binomial. Does that make sense? Okay, so my point was, the only way that you could pull out the common binomial is if they're identical, and since we noticed that they were exactly opposite, this was a plus 4 over here. I used to have a minus 4. So I pulled out a negative sign to change those signs. And now that it's common, now you could actually pull it out. That's why this one's the hardest one there is. We could pull out that common binomial of, you could copy this down, by the way. You could pull out that common binomial of 4a minus 5b. And what would be left on the inside?
3a minus 4b.
3a minus 4b. And that's it. Of course, with the correct size parentheses, you would write 4a minus 5b times 3a minus 4b. And like, let's say you're confused. You're like, man, I probably did this wrong. I'm not sure if I got this right. You could always distribute 4a times 3a is 12a squared. 4a times negative 4b, that's a negative 16ab. And there is a negative 16ab up here. And then negative 5b times 3a, that's negative 15ab, negative 15ab. And negative 5b times negative 4b is positive 20b squared, positive 20b squared. What do you think? If you understood that one, you understand any of them. And now I want you to show me. I want you and somebody next to you to try to work on this together. Start by following the steps. Step 1, separate them into 2 groups. Then factor something out of the first group, factor something out of the second group. Take a step back, factor out that common binomial. I want to pause it, and then I want to start recording when I explain it. So step 1, once again, here's the explanation. Step 1 is to separate it into 2 groups. As you could see, all I did was rewrite it with the space between it. Step 2, factor something out of the first group, factor something out of the second group. You have to factor something. Even if you can't factor, pull out a 1 at least. On this first one, these 2 terms, what could I pull out? A 2 and an x. There you go. So 2 and an x. If I do pull out that 2x, what's left over here? 2x times what gets us? Yeah. 2x times x gets us back to the 2x squared. And 2x times what gets us back to a minus 4x? Yeah, that's a minus 2. Excellent. Now, this other one, there's nothing to pull out, so I'm at least going to pull out a 1. That's right. And if I do pull out a 1, what's left over on the inside? The same exact thing, the x and the minus 2, right? The x doesn't change, the minus 2 doesn't change. 1 times x takes you back to x, 1 times minus 2 takes you back to minus 2. That was step 2. Now, step 3, you take a step back and you pull out the common binomial of x minus 2. You pull it out right here and put it right here in the front. So this x minus 2 and this x minus 2 is going to come out right here into the front. And I'm going to keep it with the same color so you guys could see how easy it is. It comes out to the front. And on the inside, if this is gone, this is the only thing left. If this is gone, then this is the only thing left. So what's left on the inside? The 2x and the plus 1. So 2x plus 1. Correct size parentheses, x minus 2, 2x plus 1. How about number 4? Could you do number 4? I'm going to pause it. Go for it. Step 1, separate it into 2 groups. Step 2, factor something out of the first group, factor something out of the second group. What could you pull out of the first group?
2x.
2x. 2x. You see, there's a multiple of 2 in both of them. You can pull that out. And there's x's in both of them. The maximum amount of x's is 1. So 2x is your GCF. Now you got to think, 2x times what gets you back to 2x squared? That's going to be a single x. And then 2x times what gets you back to a 2x? That would be a plus 1. Everybody got that. On this other group, what could I pull out? A 3. So you're going to put a plus 3 right there. And when you distribute backwards, right? You're thinking of distributed property backwards. 3 times what gets you back to a 3x? A single x. And then 3 times what gets you back to a 3? A 1, a plus 1. Now, this is a really good thing because we have a common binomial in both that we're going to be able to pull out. So I like to do some exaggerated parentheses, and I like to pull out that common binomial and just write it out here as one binomial. That'd be an x plus 1 right there. And what's left on the inside, if you pull this out, you're going to have a 2x left over and a 3. And that's exactly what we have left over on the inside, 2x plus 3. And here we go, final answer with the correct size parentheses, x plus 1, 2x plus 3. And that's it. Ladies and gentlemen, you now know how to factor by grouping. However, just because you understand it, first of all, we're going to stop right here. Tomorrow, we're going to call this day 3. We're going to continue with this tomorrow. But for now, I want you to go back to yesterday's worksheet. Yesterday's worksheet, we did 1 through 12 all. And we had you stop on 12. Why is that? Because 13, 14, and 15, actually 13 through 18, the rest of the front side of the worksheet is all about factoring by grouping. So on all of these, you need to separate it into two groups, and then factor something out of each group, take a step back, factor the common binomial out of both, and you'll be able to get to your final answer using the grouping method. However, I want to do a couple of these with you, or at least one of them with you. Check this out. Number 15. 15 is a good one to do. Let's all look at 15 together. Take out that worksheet. Step one is to separate it into two groups. Now, first of all, the first method that we learned was pulling out the GCF, and that should always be the first method that you try. Okay? So if you actually look at 1, 2, 3, at all four terms, there's actually a GCF you could pull out. 2. So you could pull out a 2. Okay? What the heck?
Why is it like that?
Why like that? Because we're going to have parentheses within parentheses, and brackets, they just look a little bit nicer. So if you do pull out a 2 from all your terms, on the inside you're going to have a 2b squared, you're going to have a minus 6b, and then I'm going to leave some space, and if you pull out a 2 from here, it's going to be a 1b, a positive 1b, and if you pull out a 2 from here, it's going to be a minus 3. So I pulled out this red 2, and we're going to zoom in, and we're going to do factoring by grouping right here, okay? So factoring by grouping right there, you're going to look at the first group, and you're going to pull out a GCF from that first group. What could I pull out of there? 2 and 2 and a B. So 2B is my GCF. If I do pull out a 2B, what's going to be left right here?
B.
One single B. And if I do pull out a 2B times what gets us the, negative 3. 2B times negative 3 gives us a negative 6B. Let's do the same for this other one over here. What could I pull out of this other one? Just a 1, right? I mean, you can't really pull out anything, so go ahead and pull out a 1, even though it doesn't change anything. B minus 3. Do we have a common binomial?
Yeah.
Yes, we do. So it is ready to exaggerate parentheses, pull out that common binomial of b minus 3. What do I have left on the inside? 2b plus 1. Now, I'm going to write it with the correct size parentheses. This is a b minus 3 times 2b plus 1. But don't forget about the original 2 that you factored out from the beginning. That needs to come down to the very front. And this is your final answer. 2 parentheses b minus 3 times 2b plus 1. Does that make sense?
But what if we just did it without doing that?
Okay, great question. I wanted somebody to ask that. What if we just did this question without pulling out the GCF right from the beginning? So this is what I'm going to do. I'm going to redo this the way you just said. Okay, so the first step is to make two groups. 4b squared minus 12b space plus 2b minus 6. Second step, factor something out of the first group. What would that be? 4b. What would be left on the inside? A b and a negative 3. Okay, and now pull something out of the second group. What would that be? That would be a positive 2. What would be left on the inside? B minus 3. Okay. Next step, big parentheses. Pull out the common binomial. Common binomial is what? B minus 3. What's left on the inside? 4b plus 2. So you're thinking, this is my answer, b minus 3 times 4b plus 2. But remember, the instructions are to factor, right? And this is correct. However, if you look at the inside of the parentheses, there's a b minus 3, and there's nothing else you could do here. There's nothing else you could do here. But when you look at this binomial, it actually has something in common that you could pull out. What is that something in common that you could pull out? A 2. Bless you. Right? The 4 and 2, you could pull out a 2. So that's what you need to do. Hold on a second. So if you did pull out a 2, you could put the 2 out here, have the b minus 3, but where did this 2 come from? It came from right here. We pulled out a 2, so what would I need inside here? 2 times what gets you that 4b? 2 times 2b, right? And 2 times what will get you that 2? A 1. So I hope this makes sense, that you could have pulled the 2 out from here, and you'd end up with the same identical answer as over here. Check it out.
Wait, how did